Okay, so we're going to talk about organizing and displaying data. And basically, excuse me, we're going to talk about reading graphs and understanding graphs. And most of this is stuff that you've seen before, but maybe you've made some incorrect analysis of it. All right, we were talking about with Mrs. Connors and the other social studies teachers about that you have to do a lot of reading of graphs in social studies, and so we're going to take a look at closer reading of graphs and be able to figure out what they say. And in this whole part we're doing from chapter 10 is going to talk a lot about graphs. And sometimes graphs are very misleading. And actually, you can make a graph tell anything you want. So if you own a company and you want to show people that your company makes a lot of money and it does really well, then you could make your graph look one way. If you wanted to show that your company's struggling, you could make a graph look totally different. And all it does is a matter of changing the window that you use for a graph or the display numbers. So we're going to talk about different graphs: bar graphs, line graphs, and circle graphs. And the first one is a bar graph. Okay. So it displays with vertical or horizontal bars. You can use either one. Bar graphs are a good way to display data that can be organized into categories. So here's the main thing here. If we can organize it into categories, then we're probably going to use a bar graph. Because that gives us a chance to be able to compare the different categories. So here we have this bar graph of casserole orders. And I made it bigger so you can see it. So 40 and Alexis can see it in the back. They've got tuna noodle, king ranch casserole, baked ziti, chicken with wild rice, and lasagna. Okay, so which one of those is your favorite? Baked ziti. Shelby likes baked ziti. All right. And lasagna. All right. Not chicken with wild rice? You made some this weekend? Oh, you're making it. All right. Okay, Cheyenne's going to make some tuna noodle casserole. Okay, so we're just going to use these graphs and we're going to answer some questions. So this should be pretty basic for you. Letter A, which casserole was ordered the most? All right. Pretty clear, right? All right, that we've got some lasagnas ordered the most because the bar's longer, right? Okay. About how many orders were placed? About how many? Can you read it well enough to be able to tell that? About how many total orders were placed? So sometimes you have to estimate. That it's not obvious how many there are, but you have to do some estimating. And that's why it says about how many. So let's see. Let's take each one and take a look at it. All right, so we've got tuna noodle casserole. All right, so they're going by tens, right? Okay, so we have to be able to read the bottom here is going by tens. So they've got a little over 40 and maybe about, I don't know, about 45, right? Is that what it looks like? Okay. So we've got about 45 for tuna noodle. Okay. All right, and then we got king ranch. Looks like that's a little bit more than 30, maybe 32, 33, somewhere around there. Okay. Then we've got baked ziti, which is a little less than 20, right? So that number might be approximately 19, 18, okay, somewhere close to there. We got wild rice, which that's between 20 and 30, so about 30 there for wild rice. So probably around 28, 27. And then lasagna, which they really help us out there. We know that lasagna is 6 So we'll take those numbers and we'll add them together. So we've got, what do we say, about 45 plus 33 plus 18 plus, what was that, 28 and plus 60, which gives us an approximate number of what? 185? Okay, 100. All right, so approximately 184 orders. Now, do you guys understand this symbol that I put here? Okay, so when we don't know the exact value, right, then we use a squiggly equals sign, which means approximately. Means I don't know what it is exactly, but I'm going to give you a close answer to it. And so whenever you're approximating, you always want to do that. Okay. All right, letter C. About how many more tuna noodle casseroles were ordered than King Ranch casseroles? About how many more? Okay. According to the numbers I have here, it would be 12, right? Because I said tuna noodle was about 45 and King Ranch was about 33. So according to these numbers, then there would be approximately 12 more tuna noodle. And the last question says, about what percent of the total orders were for baked ziti? How do you find the percent? What do we do? Nolan, how do you find the percent? Okay, so according to my numbers then that I've got, there's 18 baked ziti. Okay, 18 over 100. So there's only 100 orders there? Right, we'd have to do 18 divided by how many orders there are to find that percent. And so what is 18 divided by 184? So that's approximately, okay, 9.7? Okay, approximately 9.7%. Okay. All right, so we found that because we did 18 divided by 184, the total number of orders. So bar graph gives us an estimate. Sometimes it's a little more exact. Estimate of how many things that there were for certain categories. So we use a bar graph when we're talking about working with categories. Okay. Those answers all make sense? Okay. All right. Sometimes they use a double bar graph. And a double bar graph can be used to compare two sets of data. Right, so we're going to compare two data sets when we're using a double bar graph. Right. And the double bar graph has a key to help you distinguish between the two sets of data. So here we have an example 2, customer satisfaction with competing SUVs. And they're comparing their safety, price, cargo, comfort, and mileage. Wish that was the miles per gallon that they got when they compare the mileage there. It'd be nice to be able to find an SUV that got 50 miles a gallon, wouldn't it? Yeah. Right. So here we're going to answer these two questions. Which feature received the same satisfaction rating for each SUV? letter A is cargo gave us the same satisfaction rating. Okay, they could store the same stuff in them. And letter B, which one received a better rating for gas mileage? All right, so if we look at mileage, we can see there's the black and gray. The gray bar is higher than the black one, so then we would say that SUV Y has a better gas mileage. Really, what's missing from this? I don't think that has to do with their actual mileage, obviously, does it? What's that? Okay. So let's talk about this for a second, because there's one thing that's missing. It doesn't tell us what this, they don't label the y-axis here, okay? We got 20, 40, 60, 80, and I guess the next number would be 100, right? Okay. You got a question? Okay, just a second. Okay. And so we're not sure what exactly these numbers, maybe it's percent of people that had better or something like that. So you need to make sure that you understand when you're looking at these, right, exactly what these numbers mean, and so that should be explained. All right, is it just that however many people they were talking to, that many people said that mileage was better than for the one than the other? Okay? So you have to make sure you know what everything means when you're making a graph too, so that the people who are reading the graph understand it. Okay? A line graph displays data using line segments. Line graphs are a good way to display data that changes over a period of time. So if we're focusing on changes that happen over a period of time, we want to use a line graph instead of a bar graph. Well, when we show our grades on your graph that you're going to be doing for class, keeping track of your goal, that is a line graph, because we're going to show how it changes over time, right? Okay? So there's a very good application of it right there. Okay? So here we're going to use this line graph to answer these questions. Okay? And the first one is, at what time was the humidity the lowest? Can you see that all right, Justin? All right. So what do you think it is, Justin? When's the humidity the lowest? Okay. At 4 a.m. Okay. So we're looking for where it's on the, where it's at the lowest spot. And this is another thing where we could use that also, right? Use a straight edge to check it. Right? So 4 a.m. here. Okay. And during which 4-hour time period did the humidity increase the most? Which one did it increase the most? Charlotte, can you tell? Okay. And why do you think it would be 12 p.m. to 4 p.m.? Okay, it goes up the most, all right? What's another way we could say that when we're talking about a line that it goes up the most? Is there another terminology we could use? Hmm? Increases the most? Okay, anybody know of any other thing that we might be able to say? Caitlin, do you know something else we could say? No? All right. Okay, all right. So those are a couple things. Nolan, what else? Okay, all right, the incline. So the word I was looking for is steepest. okay, where it has the steepest slope or the steepest incline or increases the most, all right? So this would be from 12 p.m. to 4 p.m. and where we have the largest increase. Or you can think of it as the steepest line. Okay. Good. Kind of tough to tell there, though, isn't it? From 8 a.m. to noon, it's almost the same, isn't it? Okay, those are pretty close, but we have to look for when is the line the steepest. All right? Good. Okay. Double line graph can be used to compare how two related data sets change over time. The one thing you have to be careful of is when you're dealing with things where like a double bar graph or a double line graph is you have to check out the key. Make sure you're reading it correctly. So in this case, the darker lines that have triangles, or diamonds I should say, is for station A, and the ones with the circles, which is the grayer ones, those are for station B. So this is prices for regular gasoline. Wow, that's definitely not Michigan right now, is it? Okay. It's been a long time since the gasoline prices were in the $1.20 range. Okay. Sure would be nice if it got back there, wouldn't it? Okay. How many of you are driving? Anybody yet? Just Mitch? Okay. You feel it every day. So we're going to use this double line graph then. So it says, in which month did station A charge more than station B? Which month did station A, which is the diamonds, charge more than station B, the circles? All right, so let's see. So we're looking for when the black is higher, right? So we follow the black, it's lower here. Use my smiley faces here. Right? So black is lower, lower, lower. Looks like it's the same. Oh, there it's higher, isn't it? Okay. What month is that? May. All right. So during the month of May, all right, station A was. Oh, now, do you guys ever pay attention to the gas prices? I know that, right? Okay, how many people drive Mount Hope Road? Ride at Mount Hope Road a lot. Okay, all right, just a few. Do you ever pay attention to which station is higher, Buddy's or Mug and Bops? Okay, the one by the highway, Mug and Bops, is almost always higher, isn't it? Okay, rarely is it lower. So this is something to remember, that if you need gas, you're usually going to want to buy it in town instead of before you get out of town. Put it out there by the highway, and they say, oh, we can charge a little bit more here. Right, we got all those people coming off the highway who are desperate for gas. Right? During which months did the stations charge the same for gasoline? During which month or months did they charge the same? Okay, so we've got here they're the same, which was in April. Okay, and over here, which is in our second J month of July. So April and July. So how many of you are really comfortable reading these graphs? Okay, I assume that probably most of you would be. But it's good little review, right? All right. Circle graphs, right? Or pie charts, sometimes they're referred to. They show parts of a whole. The entire circle represents 100% of the data, and each sector represents a percent of the total. Circle graphs are good for comparing each category of data to the whole set. All right, so we had bar graphs, which compare categories. Okay. And line graphs for looking at things over time. And a circle graph is when we definitely know parts in the whole, we're looking at comparing them. Right? So even though categories, sometimes you might have the whole thing there, okay? And you could put categories sometimes in, okay? this situation, but you would need to know all the numbers exactly to be able to do it for a circle graph. All right. So here we have this punch recipe. Right. We've got some lemon, sherbet, pineapple juice, orange juice, and ginger ale. Okay. So their first question is, which ingredients are present in equal amounts? Shelby? Okay. Pineapple juice and lemon sherbet, because those parts of the circle graph are the same. Okay. Lemon sherbet. Not sure I want to go there. That doesn't sound very good, does it? Okay. All right, and which ingredient makes up half the volume of the punch? Easy one there, ginger ale. Now, how many of you know how to make all those graphs then? Okay. You feel comfortable making them even? Okay. Charlotte? Can you make all those graphs? All right. Okay. The last example then talks about choosing which kind of graph to make. And we're not going to really do, this is, the example I have up here on the board is exactly what's on in your handout there, or for chapter 10. And I just kind of threw up here because I just want to focus on a couple things just for a moment. Okay? Just to remind you of when you should use which kind. So letter A here, it shows us livestock show entries. That gives us some animals and how many animals. So here we have a situation where we have categories. Now, I also know the number of animals there are, but I don't know if that was every animal that was at this livestock show either. So I don't know if it was the whole thing, but I do know there's different categories, so I could display it in a bar graph, okay? Because they show me specific categories, but they're really not talking about the whole complete thing. Okay? Now make sure that when you would draw one of these, make sure that you label your x-axis, okay? Label the y-axis, or how many there are. So the number of animals would be appropriate to put here, and what animals across the bottom of it then. Letter B, here they have a division of crops, okay? So they've divided something up. So if they divided something up, they've divided up a whole thing, right? So since they're talking about all of their crops then, a circle graph would be more appropriate here because it tells us how much of the whole they're using, okay? So we would have to do a little bit of adding here to find out what the whole amount is, but then we could display them as percentages in a circle graph. How far is it all the way around the circle graph? Okay, all right, good. I knew that. Okay, 360 degrees. Okay. And then the last type here is they have Shinnick College enrollment. They talk about years, and they talk about how many students there are. So here we're talking about, since it's a change in time then that would be, a line graph would be the appropriate model for that then. Okay? So make sure you check them before you